I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this series for advanced functions, we have taken each and every chapter. There are lessons based on the concepts. These are being followed by practice test questions and quizzes. We have taken application and thinking questions for the benefit of the student. In this video, I'm going to discuss with you two questions which are similar. They are thinking and application questions based on the very first unit, in fact, the first lesson of advanced functions, the functions itself. As you can see on the screen, there are two questions, they are related. I'd like you to pause the video, understand them, and solve. Now, these are very important from examination point of view. Question number one here is: two new walls are built to enclose a rectangular meditation area in a corner of a hall as shown in the figure. The total length of the walls is 120 meters. The length of the wall is twice as long as length of the width. Explain why L equals to 2W. Let f of L be the sum of length and width of the wall. Find the equation for f of L. Graph the function f of L. Find the length and width of the new wall. The diagram is given to you. I would like you to pause the video, answer this question, and then move on to the second one. So that is the length of the wall and this is the width of the wall which is being considered. Here is question number 2, which is extremely useful from test point of view. It has been seen a couple of times in previous test papers. A 600-meter fence is used to enclose a rectangular pen area within partition as shown in the figure. So that's the partition which is shown in the figure. The four parts I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. Let me thank all the subscribers and viewers for posting their suggestions. Based on that, we have a complete series on advanced functions now, well organized. Each and every chapter is dealt in detail, is being followed up with worksheets and test paper type examples. In this video, we are going to discuss two examples which has been seen in previous test papers in the category of thinking and application. The questions are before you. I'd like you to pause the video, read them out, answer, and then look into my suggestions. We have also given the related diagrams to help you answer them easily. Question number 1 here is: two new walls are built to enclose a rectangular meditation area in a corner of a hall as shown in the figure. So that's the corner where we have this meditation area, length L, width W. The total length of the walls is 120 meters. The length of the wall is twice as long as the length of the width. So we have four parts to answer. First one, explain why L equals to 2W. B, let f of L be the sum of length and the width of the wall. Find the equation of f of L. C, graph the function f of L. D, Find the length and width of the new wall. So that becomes the first question. Here is the second question. A 600-meter fence is used to enclose a rectangular pen area with a partition as shown in the figure. So when we say a partition, is this partition over the rectangle, correct? 5 parts to this is explain why width is 200 minus 2 over L, 2 over 3L. B, write area as a function of width. Let A, W be the enclosed area. Find the equation of A as a function of width. Graph the function AW. Find the domain of the function. Determine the dimensions that will provide maximum enclosed area. Right? So these are the two questions for you, very much related, but help you organize how to solve thinking and application questions. Correct? So let's go through this process of solving such questions. So when you read a question, you have to highlight the important areas which we are talking about. The question says, two new walls are built to enclose rectangular meditation area in a corner of a hall as shown in the figure. Normally, figure may not be given to you. So in that case, you have to sketch a figure, right? The total length of the wall is 120 meters. So this total length of the wall is 120 meters, means length plus width, correct? So that gives you one equation. So we can write this as total length. We can write total length. Length plus W. Then the length of the wall is twice as long as the length of the width. So if L is the length, so we are also given that length is twice the width. Now the first equation is explain why length is twice the width. So that is answered because we are already given that the length of the wall is twice as long as the length of the width. So that is given to us, and therefore we have answered part A, which is L equals to 2W. Now part B is let f of L be the sum of length and the width of the wall. So f of L means it is a function, right, which gives you the length, total length, sum of L and W. So this particular function, which we call total length, is basically f of L, right? So we could write this as f of L. Is this clear to you? So that becomes the total length. Let me write now as total length here. Is that clear to you? So we do get part B partly. This is not a function of W, right? So it is combination. So what you should do here is that you have to write W instead of L, right? So you have to rearrange the given equation. So from here we can divide by 2, and now we can say that width is actually equals to half of length, right? So we get our equation. Let's call this as equation 2. And let's call this as our equation 1. Now, if I substitute 2 in 1, then what do I get? I get that the function of total length is basically L plus width can be replaced by L by 2, right? So now we can combine these. So we get what? 2L plus L over 2, and that gives you the function f of L equals to 2 plus 1 is 3, so we get 3 over 2L. Is that clear to you? So now we get the answer for f of L, which is our equation 3. And that is how we are going to do part B. Is this clear to you? So f of L means that the only variable has to be the length. Now part C is graph the function f of L. So how will you graph this function? Well, this is a straight line, correct? So on a straight line, as we have seen, we can now graph it here. We know that it has to be positive, so we can actually draw a line like this, taking a point, which is the slope, right? So we basically want the slope of the line m as 3 by 2. Is that clear to you? This is a direct function, correct? Going through origin. So it goes through the origin. And you can take a point at 2 when the x value is 2, the y value is 3, correct? So this is the function f of L, and here you have the length L. So that becomes the graph of the function. Now, what should be the domain and range? That's also a part of this, which is find the length and width of the new wall. Now, we are also given that the length is 120 meters, right? So total length is 120 meters. So that means we are also given that f of L is basically equal to 120. Is that clear to you? So we can substitute 120 meters here over 3 over 2L, and this can help us find the length. So this implies that length is equal to 2 over 3 of 120, and that can be simplified, and so you get 80 meters as the total length. So length could be 80. So maximum we can actually go like this, that think about a break in between, right? So this is too small a scale, but anyways, you can say this is 20 and 30. Okay, in that case we could say this is like 80, and that point will be 120, because total length is 120, and therefore we'll have a line which will go from 0 to the point 80, 120. Is that clear to you? So that becomes the sketch for this particular question. It's very important, right? Do not draw an arrow here. That is important. So that gives us the graph of the function, and from the diagram we can find the length and the width of the new wall. Well, we just calculated also, and so we can say that part C is length is equals to 80 meters and width is half of length, correct? So which is half of 80, and that is 40 meters. Is that clear to you? So that is how you're going to answer this particular question. Well, we could have asked you more questions here. What is the domain and range for the function, correct? So that is how you have test questions based on this particular application. So let's take a good look at the solution itself. Here is the solution before you, or just typed out. You can have a good look at it. The graph, as we were discussing, will be terminating at 80, right? So this is scale is 80, not 8. So think this is 80 and that is 120. Is that clear to you? So that is how this particular graph is, and the function f of L. Perfect. So I hope you have understood how do we do such a question. So that was regarding the length of the fence. Now let's look into the second question. It says a 600-meter fence is used to enclose the rectangular pen area with partition as shown in the figure. So the total length, that means these two lengths, 2L, and these are three widths, correct? The variables are already defined, correct? If the diagram was not given to you, you have to write down let the length be L and width be W. So that let statement will come. Now in this particular case, we know we have two lengths, right, plus 3 Ws, and that is equal to 600. So that is what it means when we say a 600-meter fence is enclosing this area. Now, let's try to do question number 2A. Explain why W is 200 minus 2 over 3L. So we can rearrange from here. So we get 3W equals to 600 minus twice length. Dividing by 3, we get 600 over 3 minus 2 over 3L. And that gives you the width as 200 minus 2 over 3L. Clear? So that part is done. Now we need to find the area in terms of width. So the parameter to be used is width. So let's try to do this. Area is what? So area basically is equal to length times width. Since we want W, we have to rewrite this equation in terms of length. This is important, right? So let's rewrite this in terms of length. That means we could have rearranged this and also write what L is equal to, right? So we can say, well, 2L is equals to 600 minus 3W, or L is equal to, dividing by 2, we get 300 minus 3 by 2 width. Is this part clear to you? Correct. So we could have arranged to get, or rather isolate W. We could have done to isolate length also. Since we want the function in terms of width, we'll isolate L. Perfect. So this is the part which is kind of critical. So the area now can be written as, instead of L, we could write this as 300, or I could also do 600 minus 3W over this, right? So we could also do this, 300 minus 3 by 2 width times width. You get this idea. So if you write it in terms of W, then it becomes area as a function of width. You get the idea, right? I'll rather take half outside. Factor this half outside. So we get what? We get 600 minus 3W. Is that clear to you? Times W. So that is how I could actually rewrite my equation. And this becomes the function, right? So that is how we'll do part B, which is area as a function of width. Now this is a parabola which you can always sketch, right? So let's try to sketch the parabola. To sketch the parabola, what do we need? We need the zeros, the maximum or the minimum, as the case may be. Well, one zero is that W equals to 0. So that is, we have W here and area as a function of width on y-axis. So 1 0 we have at W equals 0. The other one is because of this, right? So which will be at 200, correct? So at W equals to 200. So at 200 also we have a 0. So from here we know that zeros are there. So axis will be where? So axis will be right in the middle. That means 0 plus 200 divided by 2. So at 100 we have axis. So let me draw the axis in a different ink. Let us say that becomes the axis, correct? So we can substitute 100. So we get A of 100 equals to half of 600 minus 300, correct? We substitute 100 for width, correct? So that gives us the value. So this is what? This is half of 600 minus 300 is 300 times 100, correct? 2 more zeros. So this is, you can calculate the value from here. So 600, 300 divide by 2. So 300 divided by 2, 30 divided by 2 is 15, 150 and 2 more zeros, correct? So we get 150,000 as the maximum value. You can now sketch the graph, which will look like this. A parabola, symmetric about the axis, right? And this point here will be what? Will be 150,000 units meters square, right? where this is meters. Is that clear to you? So that becomes the unit, and so we have the graph here. Now, so we've done the graph. We need to find the domain of this particular function. So now you can write the domain here. We can say, well, the domain of the function is the variable being width w, as w belongs to real numbers, where it is between 0 to 150, 100. So 15,000, right? So 0 to, let me write width here, less than equal to 150, 100, 15,000. Is that clear to you? Now, part E is determine the dimensions that will provide maximum enclosed area. So, of course, width is 100 here. So, for maximum enclosed area, width is equal to 100. We'll go with the vertex, right? And if width is 100, what is length? We can now find what length is. So, length will be, you can take away width, which is 100, 100, 100. 300 is taken away. You get 200. Divide by, take away 200 from 600, and then divide by 2 to get the length, right? So we have this as 100, 100, 100. So that is 300. And these two will be what? 150 and 150, 300, 300, 600. Or calculate, right? So less space is here. We could just calculate here. We got 300 minus 3 by 2 of 100. 3 by 2 of 100, right? So 300 minus 150, which gives you 150. Is that clear to you? So we get the length as 150 meters. So that is how you are going to solve this particular question. Is this clear to you? Perfect. So let's have a neat look at the solution. So here is the solution before you, the same question, the way we did. Now you can see, basically, we start with the perimeter, which is 600, which is sum of 2 lengths and 3 widths, right? These are the 3 widths. You can isolate the variable, right, in terms of width and also length. Since we wanted this as a function of width, we have to write this as a function of width, right? So we have to write length in terms of width. Area is product of length and width. When you substitute, you get this function. To find the domain, we know everything should be positive. So that means 600 minus 300 has to be greater than equal to 0. So you can isolate taking 3w on the right hand side, and that gives you width to be less than equal to 200, right? So that becomes the domain of the function. So as we had calculated, this domain is from 0 to 200, right? Now, how do we calculate the maximum? Once again, find the axis. The idea is to find the axis and then the vertex, right? So we found the vertex. And that vertex came out to be at 100 and 150. Area will be 150, 100. Okay? So when you substitute this value in area, you get this as 150, 100 as we did the calculation. So that is how you're going to provide the solution. I hope the steps are absolutely clear. Well, we are conducting classes. If you want to join my classes, you can always send an email on the address given here, and then you can learn from me. I hope concept is absolutely clear. Feel free to write your comments and share your views. Thanks for your time and all the best.